Okay, so limiting reactants is a more specific part of the stoichiometry process. And so I want to make sure you understand them. So what is a limiting reactant? Well, a limiting reactant is also known as a limiting reagent, and it's a reactant that limits the amount of product that can be formed. So let's say you're trying to make a cake and you need 3 eggs and you only have 2. Then eggs would be your limiting reactant. So we could look at this with food items, which I think is a little bit easier to understand. Whereas if I have something like this, and let's say I have 5 grams of this, 5 grams of this, it's not obvious to know which one is going to run out first. So to recognize that you have a limiting reactant problem, you need to have 2 quantities given. So what we did with the original stoichiometry, we just had, let's say, the quantity of nitrogen given. For a limiting reactant problem, you will have 2 quantities. So make sure you always balance your reaction before you complete the limiting reactant process, because if you don't, you may determine the wrong limiting reactant, and then everything will be based off of your reactant amount of the limiting reactant. So to determine the limiting reactant, we're going to use the first given to solve for the amount of second given used in the reaction. If the things are given to you in grams, use it in grams. If it's given to you in moles, use moles. If it's in liters, use liters. And it all boils down to this inequality here. And I'm going to show you how that works. So if your amount calculated is greater than your amount given, that means that compound is the limiting reactant. If your amount calculated is less than your amount given, that means your compound is in excess. So given 5 grams of copper and 20 grams of silver nitrate and the reaction below, find the limiting reactant. Okay, so first off, let's make sure we realize this is a limiting reactant problem. We have 2 givens. So I'm going to take my 5 grams of copper and I'm going to solve for grams of silver nitrate to see who runs out first. So I'm going to convert to moles. I'm going to multiply by the mole-to-mole ratio, and then I can go from moles back to grams. Again, these masses here, those are your molar masses from the periodic table, and I found it to be 26.8 grams of silver nitrate. So this is my calculated amount of AgNO3, and in the problem statement, there was 20 available. Well, I don't have enough to react 5 grams of copper totally. I only have 20 grams. That means that silver nitrate is, in fact, my limiting reactant. So limiting reactant problems typically will look like this. So you determine your limiting reactant first, and then it often will ask for masses of something else in the problem. So using that same problem, we could find the mass of silver produced and the mass of copper 2 nitrate produced. And so notice our starting numbers are based off of our limiting reactant. So they're based off of the 20 grams of silver nitrate. We're now ignoring that 5. Okay, so we're going to take 20 grams of silver nitrate, convert it to moles, use our mole-to-mole ratio, and then moles back to grams, and then we find the 12.7 grams of silver. Just a reminder, the circled ones are molar masses, and this comes from your balanced chemical reaction. And that's the same idea for the other compound. So we have 20 grams silver nitrate, convert to moles, moles of copper 2 nitrate to copper 2 in mass, and we found it to be 11 grams. Now there's one more step that you might run into with these, is to find the excess reactant. So we could use a limiting reactant to determine the amount of excess reactant by taking the given limiting reactant amount given and calculate the amount of the other reactant. Once we know that, that will tell us the amount reacted. We could then further figure out our amount of excess by subtracting it from that given amount. So here I'm taking my limiting reactant, 20 grams of AgNO3, and I'm finding that 3.7 grams of copper is actually reacted. So to react 20 grams AgNO3, I need 3.7 grams of copper. Well, in the problem statement, I was given 5 grams. I'm going to subtract that amount reacted, and then my excess is what is left behind. So that's 5 minus the 3.7, and that gives me the 1.3 grams of copper excess. So here is our first practice problem. So I'm going to go ahead and start showing my work and talking at the same time. And so this one is not balanced. So I'm going to balance that for you. When we have 50.6 grams of MgOH2, 45 grams of HCl, and it's not clear to know who's going to run out first. This is a typical limiting reactant problem in the sense that you have two givens, but it doesn't directly ask for the limiting reactant. So be careful of this type. So I'm going to take my 50.6 grams of MgOH2, and I'm going to go ahead and calculate how much HCl you would need for that to happen. So this is 58.3 grams is the molar mass. And then we take 1 mole MgOH2 to 2 mole HCl. Then we take 1 mole HCl, 36.5 grams HCl, and I found it to be 63.4 grams of HCl. So this is my amount calculated as 63.4 grams HCl. I had 45 grams HCl available, which means that HCl is going to run out first because I don't have enough to react totally with that magnesium hydroxide. So now that I know my limiting reactant, I'm going to take my 45 grams of HCl. I'm going to convert to moles because we compare everything by moles. And now I can find my magnesium chloride produced. There are 2 moles of HCl per 1 mole MgCl2, and then 1 mole MgCl2 is equal to 95.2 grams MgCl2. So I found that to be 58.7 grams of magnesium chloride. Now we could do a follow-up question, is how much excess reactant is left over? So given the 45 grams of HCl, let's actually find how much magnesium hydroxide is used. So I'm just going to add that problem right now. So 2 moles of HCl to 1 mole MgOH2. And there's 1 mole MgOH2. That's 58.3 grams. So I found that to be 35.9 grams of MgOH2. And this is reacted. Now, if your reacted number is ever larger than what was given, then you have your limiting reactant switched. So to find my excess, I'm going to take 50.6 minus the 35.9 grams reacted, and I found it to be 14.7 grams of MgOH2 in excess. Okay. One other part is the yield. So the actual yield is the amount actually produced when the lab was done. This value would have to be given to you. You can't calculate it, or maybe you can find it in a lab situation. Theoretically, this should actually be smaller than your actual yield, unless you have some major source of error, like a sample isn't totally dry. The theoretical yield is the amount predicted to be produced through stoichiometric calculations. You calculate the quantity of the thing that was given to you as an actual yield. So to find your percent yield, you take your actual divided by your theoretical times 100. So here's an example problem. You produced 30 grams of water. You're anticipating to produce 56.25 grams of water. What is the percent yield? So we just divide those two numbers, multiply by 100, and we found it to be 53.3%. So this person probably didn't do a very good job, or that process could be enhanced. So I have some practice problems here. So notice number 1 is based off of the calculations we just did. So it's exactly the same, but it's asking for the percent yield. And you'll notice that they gave us what the actual yield is. Okay, so the percent yield is going to be the 55.4 gram, which was actually given. And we had found 58.7 grams of magnesium chloride on the previous slide. So that ends up being 94.3%. which is a fairly good process. So for this next one, determine the amount of each product, the alarmed amount of excess. You have 10 grams of each. The reaction is not balanced, so always double check that. So I'm just going to go ahead and write my work. I'm going to take my mass of my first given to find my second given, so I can use that to compare. So 2 moles of H2SO4, again, that comes from the balanced reaction, to 1 mole MnO2. 1 mole H2SO4 is 98 grams. So I found it to be 22.6 grams of H2SO4. So if we compare 22.6, our calculated of H2SO4 is much larger than the 10 grams given. Therefore, H2SO4 is our limiting reactant. Okay, so this one is going to take a little bit of time. So we're going to take 10 grams H2SO4, and we're going to have to use that for the basis of all our calculations. And so what you'll find is we're just going to change this mole to mole ratio for each part for what we're solving for. And the biggest part is just writing out the brackets takes a very long time. And it's hard to not get sloppy with them. And just keep in mind, you only have 1 mole for everything except for that middle bracket with the mole to mole ratio. So I found that to be 12.60 grams of MnSO4 And I'm going to erase this top part and continue solving this problem on the top, because there's no way I'm going to fit all this. So 10 grams H2SO4. Notice it's going to be that same process at the beginning. 98 grams. 2 mole H2SO4. And now it's going to have 2 moles of water. 1 mole water. It's 18 grams of water. So that's 1.84 grams of water. This first part's going to be identical. I'm just going to try to save a little bit of time here. So the beginning would be the exact same, but this middle bracket's going to change. And this is to find our MnO2 reacted. Always check that your brackets are canceling. That will help you in making sure you haven't made a mistake. So then our excess is going to be, we had 10 available, minus 4.43. So that's about 5.57 grams of MnO2 and excess. Now I do have additional practice problems here. What I'm going to do is just put the answers so you can try this on your own. You'll find that aluminum is excess on this one. And so this is going to be 3.2 grams of silver when you solve it out. 2.1 grams of aluminum nitrate. And 4.74 grams of excess Al. And I'm going to go ahead and write the reaction for you in case you have trouble with that part. So that would be a good practice to make sure you can do that. And then this percent yield, this one's actually faster. You have the 1.279 for our actual. They gave us the theoretical for the percent yield. So 94.6% is pretty good. And then here are some videos. I think Tyler DeWitt's great on this stuff. Again, I like the Organic Chemistry Tutor. Paul Anderson Bozeman Science is also good. And then lots and lots of practice. There's a POGL, there's different worksheets and keys. And don't forget, you always have CK12. Remember, CK12 has a lot of great practice too.